Hello, everyone. My name is Andreea Turcu, and today we are going to tackle some questions about predictions. How do we move from wondering what might happen to actually getting an answer? I'm the head of global training here at H2O University, and the next hour we're going to tackle and explore a new approach called Tabular Foundation Models. We'll look at what they are, why they are generating so much interest, and most importantly, we'll see them in action in real time. So let's get started. I'm going to share my screen here and move to the next slide. Okay, so let me show you what I think is one of the strangest things happening in AI today. Most of us can now open any AI assistant and generate a report, summarize a document, analyze notes, or brainstorm ideas in seconds. What would have felt impossible a few years ago now feels completely normal. But then we ask a different type of questions, not write something for me, but tell me something. Which customers are likely to churn? That's one of the frequent questions we have from our customers. What demands should we expect next quarter? Which opportunities deserve attention? And for many organizations, that simple question suddenly becomes a project, and we've seen that so many times. Data has to be prepared, people get involved, priorities need to align, and the answer often arrives weeks later. And that's the interesting contrast. AI has become incredibly accessible for generating content, but predictive questions about business data are open still and are often expensive to answer. So what if asking predictive questions became dramatically easier as well? That's really the idea we're going to explore today. For those of you who may not be familiar with H2O AI, we've spent more than a decade helping organizations generate value from predictive AI. Long before generative AI became mainstream, for example, our teams were already using machine learning to tackle problems like fraud detection, forecasting, risk assessment, pricing optimization, or customer retention. What's interesting is that most of those use cases relied on the same thing: structured business data, customer records, claims, transactions, the kind of data that powers everyday business decisions. And over the years, models have improved. Infrastructure has improved. AutoML simplified many workflows, but one challenge remained remarkably consistent. Organizations always had more prediction opportunities than they could realistically support. And I'm not sure if you're joining me in this assertion, but I really think it's true, and this is what we're seeing in the market. There were always more questions than there were resources. The foundation models arrived, large language models, and changed how people interact with AI nowadays. Tasks that once required specialized expertise suddenly became accessible through a simple prompt. And naturally, that raised an interesting question for us. If foundation models transformed how we work with language, could similar ideas transform how we work with business data? Not because organizations need more data. Most organizations already have plenty of data. Not because they need more dashboards. Most organizations already have dashboards, but because they need a faster path from data to decisions. And that's really what today's session is all about. Before we dive in, here's the roadmap for today's session. We'll start by looking at why predictive questions are still surprisingly difficult to answer, even in a world where generative AI has become incredibly accessible. Then we'll explore a different approach: tabular foundation models. You might have heard of them, what they are, how they work, and why they're generating so much interest around structured business data. And after that, We'll move to a live demonstration using TabH2O's H2O AI application inside Excel, working with business data and generating predictions together like this. And finally, we'll wrap up with practical considerations. So don't hesitate, please, to ask questions in the Q&A section if you have any. My colleagues will answer to them, and by the end of this session, I'll also get to them in case they haven't been answered. So if you've watched AI over the last few years, what you might have noticed is that most of the breakthroughs happened around text, images, and content generation. What used to feel impossible now feels completely normal. But here is the thing that started becoming interesting to us at H2O AI. Most of the valuable data inside an organization doesn't look like a paragraph. It doesn't look like a prompt. It looks like rows and columns, and it's still the case for decades. It has been the case, and it's still the case today. Customer records, orders, inventory levels, the data businesses actually run on. And that's where the disconnect appears. Foundation models dramatically simplified how we work with language, but many predictive questions about business data still require specialized workflows, multiple tools, and a lot of patience. The problem isn't a lack of data. Most organizations are drowning in data, as I have said. The problem is the distance between having the data and getting the answer. And that's really the theme of today's discussion. How do we reduce that distance? That's the question. Now, when I say rows and columns, I'm not describing some exotic data set hidden away in a data warehouse. I'm really describing something you've probably worked with already today. What people hear in the world tabular, this sometimes sounds more technical than it really is. But if you've used Excel, Salesforce, a CRM, Google Spreadsheet, for example, or a database export, you've already worked with tabular data. And what's interesting isn't that what tabular data is. It's how much of the world's business value is represented in this format. And not to mention across a multitude of industries, all the industries, different terminology, different types of data, but they are all having the same underlying structure. While much of the AI conversation has focused on text, video, audio, many of the decisions that impact revenue, risk, growth, and efficiency still depend on rows and columns. And in many ways, tables remain what I consider the language of business. And I'd like you to remember this picture for a moment. Notice the question marks in the last column here on the slides. In about 20 minutes, we're going to come back to a spreadsheet just like this and watch those missing values get filled live in a matter of fractions of seconds. But first, let's talk about why turning valuable business data into predictions has traditionally been so difficult. And I think that's one of the questions that has been a while in your mind as well, since you have joined this webinar. When people hear discussions about tabular foundation models, one of the first questions that comes up is, if machine learning already works, what's the problem they're trying to solve? And that's a fair question. Traditional machine learning can produce excellent results. We have seen them. Maybe if you're working on data science projects, you have seen that already in real life. Many organizations are already using it successfully for forecasting, fraud detection, risk assessment, all sorts of analytics, such as customer analytics, and many other use cases. So this isn't a story about machine learning failing. It's a story about friction. Let's take a relatively simple business question. Which customers are likely to churn next quarter? The question sounds straightforward and direct, but getting to the answer often involves data preparation, feature engineering, model training, evaluation, deployment, monitoring, and maintenance, as you see on the screen. Every step exists here for a reason. Every step adds value. The challenge is that the effort required is often disproportionate to the question being asked. Now, multiply that across dozens of or even hundreds of prediction opportunities inside an organization. Very quickly, the bottleneck stops being ideas. We have plenty of them. It becomes capacity. There are simply more questions than most teams can realistically support. And that's the issue. And that naturally leads us to what I call the prediction gap. The prediction gap is the gap between the questions organizations would like answered and the questions that are practical to answer. What's interesting here is that most organizations already know what information would help them take better decisions. That's true. They know the questions, they have the data, they understand the value. The challenge is that every predictive question comes with a cost in terms of time, in terms of resources, expertise, infrastructure, coordination, collaboration, you name it. Eventually, something predictable happens. Organizations focus on a relatively small number of predictive projects, while many potentially valuable questions never get explored at all. Not because they aren't important. We know they are important. Not because the data doesn't exist. We know data exists in the majority of the cases. But because obtaining the prediction requires too much effort. Is that simple or that complicated, as a matter of fact, in this case? And that's really the opportunity. If we can reduce the cost of asking predictive questions, organizations can start exploring far more possibilities than they can today. That's why tabular foundation models are attracting so much attention nowadays. They have the potential to narrow the distance between business questions and the business answers I was talking earlier. And so let's forget about the technology for just a moment. Imagine two people receiving the same exact spreadsheet. Neither of them has ever seen that specific data before. The first person is smart, analytical, motivated, and they've never worked with business data. The second person has spent 20 years analyzing reports across various types of industries, like banking, manufacturing, retail, 20 years of patterns. Who spots the signals first? Just think for a moment. That smart, analytical, motivated person that never worked with business data, or the second person that has like 20 years of experience in various domains? Usually it is the second person, the experienced analyst, not because they've seen that exact spreadsheet before, but because they've seen hundreds of similar situations. They recognize relationships, they recognize warning signs, they develop intuition. And in many ways, that's a useful way to think about tabular foundation models. Just as large language models learn patterns across language, tabular foundation models learn patterns across tables. Let it sink for a moment. Large language models learn patterns across language. Tabular foundation models are the equivalent of large language models, but for tables. They learn patterns across tables. They learn relationships between columns, behaviors that appear repeatedly across datasets. They learn structures that show up again and again in the business data. And the important idea here is that they don't start from a blank page. So traditional machine learning often starts every new problem from scratch. A tabular foundation model starts with prior experience. And that's where the shift becomes interesting in terms of tabular foundation models. The traditional question is often, which model should I build? The new question becomes here, what would we like to predict? So it is a subtle difference, but it's a powerful one because it moves the focus away from building models and back towards solving business problems. And we are here to solve business problems. We are not here to learn about tools and how to use them. These tools are exactly what they are called, are the means to reaching a goal. So the question is, what is your goal and how can you faster arrive at that particular goal with using the least amount of resources, potentially, if there is a possibility? At this point, you might be thinking, this sounds so interesting and I get it. I get the idea. I understand what does it mean, but what does it actually look like in practice? And here is where TabH2O comes in. The idea is very simple. Bring a spreadsheet, provide examples of the data, and generate predictions at the click of a button. And there are three things I'd like you to notice on this slide. First, no model training. We are not building models from scratch or tuning hyperparameters, as we like to say in data science, or managing deployment pipelines here as they might be applied in like a super complex project in data science. The focus stays on the business question rather than the machine learning workflow. And that's why we like so much the idea of having a button that can do everything, and behind scenes you don't need to have the very technical tech savvy knowledge to be able to create predictions as you might need to when you're using machine learning or traditional machine learning models. Second, it works where people already work, in your case, directly in an Excel spreadsheet. Not because Excel is the only place predictions can happen, but because it's one of the most familiar environments for working with business data. You can do it in Google spreadsheets, etc. And third, it works with real-world data sets. Not every predictive question comes with millions of rows and a dedicated machine learning team. And you don't actually need to. Sometimes the data you have is the data you have, and you still need an answer. And if you don't get an answer and you start entering into a rabbit hole where you start mobilizing 50 people in 3 projects over 3 months period, you kind of actually lose that motivation, and you just want to find another answer somehow differently that is less cost intensive. The goal is simple here. Reduce the effort required to explore predictive questions and make prediction more accessible to the people who need it. And that's actually what we focused on when working with TabH2O. Here, this slide is just to show you a bit that TabH2O uses the labeled rows as context to understand the patterns in your data and then generates predictions for the unlabeled rows. So the idea is simple. You want outcomes based on the missing rows. You provide the rows where the outcome is missing, and those are the records you want predictions for. And we will see in just a couple of minutes what this looks like. One of the most common questions people ask is what happens to this particular data? The short answer is that your data remains your data. And we live right now in an era where we are very concerned about the data security and the data privacy. And so TabH2O from this point of view is just an add-in that you can add on your Excel spreadsheet that doesn't have any connection to the exterior world, and everything you provide to it stays within the same spreadsheet. So TabH2O processes the information needed to generate the predictions, but the data isn't stored or used to retrain the model afterwards. It is very powerful. And because prediction quality comes from the patterns within the data rather than the column themselves, organizations can also anonymize information when needed. So you don't have actually to have names of the columns given to TabH2O in order for it to work. The goal is simple here. Help you generate predictions while maintaining control over your data. And we have many clients from many industries that are preoccupied with this aspects at such a high level that it is important to provide this type of service to our customers. We've spent the first part of the session talking about the idea, what tabular foundations models are intuitively, why they matter, and how they can help reduce the distance between data and decisions. Now, I'd like to shift gears a bit and move from concept to practice. So from this point on, you have two options. You're welcome to follow along with me step by step, or you can simply watch the demo and try everything yourself afterwards. Don't worry, if you miss a step, as Bruna mentioned at the beginning, this session is being recorded and will be shared with you afterwards so that you can revisit the workflow at your own pace. What I would like about this workflow to mention is how familiar it will feel. You don't need any notebooks, no model training, no infrastructure setup. You just need a spreadsheet, a business question, and a prediction, and that's it. And so on the next slide, I'll walk through the exact setup step by step and share the links with you in the chat as we move along. Okay, so I'll be sharing with you the first hyperlink in the chat. This is the hyperlink that we use for the dataset, the toy dataset that we are going to use for this session. And so from this perspective, I am going to connect here on the hyperlink that I am sharing with you. And so this is our GitHub repository where you can connect and you can click the download raw file in order to have access to the demo dataset. So this is a dataset that has a couple of opportunities, 60 records just for the demonstration purposes, and analyzes in terms of opportunities across industries, company size, region, engagement score, and all other metrics, the current pipeline value. There are opportunities that also have the next 90 days opportunity value, but there are some missing fields here at the end, 15 observations that do not have this value. So you see, like, it's a pretty simple data set for which we shouldn't create an entire machine learning project in order to answer to this simple question. This could take days, weeks sometimes. What we want to do is to see, are there methods and options that can give us the possibility to predict this at the click of a button in just a couple of seconds? And the answer with TabH2O is yes, that's the spoiler alert. Okay, so I shared the hyperlink here. Please make sure you're downloading by clicking on the download button, the file in the .csv format. Next up, I'm going to share with you the hyperlink access to the Excel Cloud Microsoft. Hoping that you have an account and you can connect to. Once again, if it's not the case, you can follow along with me and do this afterwards. So I am going to connect to the excel.cloud.microsoft place. And here I'm already connected with my user account. So please make sure you sign in. It is the place where we will be uploading our file that we just downloaded. And finally, it was shared already in the chat, the TabH2O platform itself. I'm going to put the hyperlink in the chat as well, tabh2o.h2oai.com. So this is the place where we are going to download a manifest.xml file that contains the code which will be needed in order to install this add-in on Excel for the web version. So I'm going to the tabh2o.h2oai.com, and here I arrive on this page. I need to sign in first. It's free to sign in, so don't hesitate right now, if you have the occasion, to click the sign in button. You're going to create an account for the first time. As I said, the registration is free, and your API key, which will be needed in order to generate predictions, is going to be generated automatically on the dashboard in the next step. So you have the possibility to continue with Google, but you also have the possibility to continue with a LinkedIn account. And so I'm going to connect with Google. I have a couple of emails here, and I'm already logged in on the tabh2o.ai.com webpage. And here you see a lot of different things. The first thing is that you have a button where you can click to get your API key. This is a unique key that you will need in order to generate predictions in the spreadsheet once the add-in is being installed. What you also have access to is the documentation button, where you have a lot of setups that you can do either in the notebook version, either online directly. We are not going to go into technicalities, but this is for you to know. At this place, once again, from the home page, if I click on the read docs, this is the place where I'm going to download the manifest XML file. So I'll just scroll up down actually to the last part of the page. Somewhere on the page, you can also do Command F manifest.xml. Manifest.xml. And here you are going to see a download button of the download manifest.xml file. So let's click on it and download it together. As you see, we are going to download an XML file, which we will install afterwards in Excel. So let's do just that. I'm here going to come back on excel.cloud.microsoft and upload my file. Let's upload our file first. I have the demo dataset, the opportunity value regression demo dataset. This is how it's called. And right now I'm uploading it as a CSV file that will be automatically converted in a file in Excel. Please be mindful here. You are in viewer mode. Click on editing and click on convert in order to have access to this particular file. It's exactly the same file you saw on GitHub. So the idea here is to be able to import it in Excel and to have access to an add-in that is called Open TabH2O. From my side, I already installed it. This is a one-time installation process, but I'm going to share in the incognito mode so you can also see what this looks like. Let me share my screen. Normally, this is it. Okay, so I am signed in my excel.cloud.microsoft account, and I'm going to upload once again the file. Let's say we'll upload the file here. I'm doing that just to show you how to install the add-in for the first time. We have access to the data set, 60 rows in total, and the last 15 don't have information of the opportunity value for the next 90 days. This is actually what we're searching to predict right now. Okay, so I hope everyone is following with me. So right now, what I'm going to do is to switch on the editing mode so I'm able to edit this file. And from the home page, now I'll have access to the add-ins button. I'll need to click on it, so let's click on it together. And let's click on the advanced button on the left bottom of the pop-up window that appears. So once again, I'm on the home page and I'm going to click on add-ins advanced. And here is the place where I'm going to install my manifest.xml file that has everything I need in order to install TabH2O. This is taking a bit of time. Right now, that's perfect. Here it is. What I'm going to do is to click on Upload My Add-in. So I'm going to click on Browse, and I will upload from the downloads section folder where I downloaded my manifest XML, the manifest XML file, and click on upload. And as soon as I do that, as you can see, a new tab, a new add-in was opened called Open TabH2O. If I click on it, I'll have access to everything I need to predict these 15 rows at the click of a button. Okay, so I'll go back to the non-incognito version. Perfect. Okay, so once again, what did we do up to this point? We have a file for which we want to predict 15 opportunities and see what would be the estimated value of these opportunities for the next 90 days, knowing that for the first rows, we already have a tendency, we already have a trend. And so what we did was to sign in TabH2O portal in order to get access to an API key and to the manifest file that we installed together. And so here I clicked on the Open TabH2O button and I see a couple of things. What I can do is actually to resize, so I really can resize if I want this by clicking on the three dots. I can click on the TabH2O button to be brought on the H2O TabH2O portal. I can also click on the H2O.ai to go on the website if I want to for additional information and stuff like that. And now, in order to predict these rows, I need to have an API key. So what I'm going to do is to click on the Get Your Key. And this is exactly the same portal where I was earlier. So you can arrive on the same place by getting your API key from the dashboard and click on the Copy button. So I'm going to click on the Copy button and go back and put my API key and load it. So automatically, as you can see, the source data, so the file spreadsheet has been detected. If there were multiple spreadsheets, I could have selected the one that I wanted. Here we just have one, that's why it was automatically detected. And by clicking on the load button, I can see that there are 60 rows that have been loaded with 10 columns. And so if I want, I can click on the button here of the spreadsheet and see the column name as well as the column type if I want. So I see all the 10 columns, and underneath I can see the target column that has the missing values. So if there are other columns that have missing values, they will appear here. As for the moment, we only have one single missing values in one single column. Automatically, the task has been detected as being a regression. There are two types of tasks that we can select. One of them is regression, the other one is classification. So let me go back here to explain to you what the difference is in case you don't have the opportunity to have known already. We have three types of things that can happen usually when we want to predict something. You can have questions. Will they leave? Yes or no? What color is it predicted? Yes or no? So this is a question about will something happen with an answer that is of categorical value. This is what classification means. Then we have questions such as how much will happen or how much revenue, where the answer is a numeric value, which is considered a regression. And there is another category that is called what happens next over time, and that's what we call forecasting. Today we'll focus primarily on regression because it's a natural fit for the opportunity value dataset we're using, but the workflow you'll see is very similar across classification as well. Okay. And so before we click the predict button, because here, as you can see, we have a predict button, and all we need to do is actually to click on this predict button to get the prediction. So actually, we don't need an hour for a webinar where we can have our predictions in a matter of seconds. But I really feel it's important for you to understand the underlying issues and the entire context in which this has been developed and the opportunity it presents. Let's discuss a bit about what is happening here. So before we click the predict button, there are two things worth noticing here. First, every row represents an opportunity and every column contains information we already know today, as you see. And the second, we have a target column. This is what we are trying to predict, called opportunity value in the next 90 days in USD. Some rows already have values, and as you see, these are historical opportunities where we know what happened. They provide examples the model will learn from. Other rows are blank, and those are opportunities that we are interested in because they are the ones where we're asking a question about the future. And that's really the core idea behind the workflow. Known outcomes teach, unknown outcomes get predicted. And in this case, we're asking a regression question based on everything we know today from this data set that only has 60 observations. What revenue might these opportunities generate over the next 90 days? And now we have everything we need. We know a lot about these opportunities already. What we don't know is how much revenue they might generate over the next 90 days. That's the question we are asking TabH2O to help answer. Let's see what comes back. And so let's click together on the predict button. When I'm going to click on the predict button, what happens is that all these fields are going to be filled in with the color violet. And this is the estimation and the prediction of all these rows. So let's see how difficult it is to predict something with TabH2O. That's it. Actually, the reason why you're here today is for this particular point. That's it. And yeah, the rest is history. What can I say? So let me get back to the slides. And I hope you are as surprised as I was when I first tried this particular data set, not data set, this particular tool when I installed it. And I have an entire video that I'll share the hyperlink of in the Slack channel right now in order for you to learn step by step what's happening in a classification situation, get more information about what TabH2O does and the underlying technical circumstances if you're interested in. It's a very good one, so I highly recommend you go and take a look at that video afterwards. And so before we move on in the next sections, let's pause for a second and reflect on what just happened, because the prediction itself, it's only a part of the history. What really changed is the flow, right? Like we do agree. We know how to open an Excel file. We know how to read some data, but what do we do afterwards? Well, we use traditional machine learning. Now with TabH2O, it's just like a click of a button and that's it. We have predictions that are highly accurate with models that have been developed by our Kaggle grandmasters and who have trained these models on billions of data. Traditionally, answering a predictive question often meant involving multiple teams, as we discussed at the beginning, moving data between systems, building models, validating results, waiting for days and sometimes weeks before getting an answer, involving multiple types of skills and technical teams. There were so many complications with respect to that. What we just did looked very different. We started with a spreadsheet, asked a question, and generated predictions in a matter of seconds. Now, of course, this doesn't eliminate the need for data scientists or machine learning experts. It doesn't. Complex problems still require expertise, governance, and robust machine learning workflows. But for many everyday business questions, the barrier to getting a predictive answer becomes dramatically lower. That's the real impact. You don't need yourself as a salesperson or as the CEO of a company or a VP of a department that is totally different from what data science means to understand what data science is and what are the intricacies of machine learning models in order to be able to use this application. And that's the shift I want you to remember. It's not simply a faster process. It's a short distance between a question and a decision. The conversation starts to move away from how do we build a model and toward what would we like to know. Because how do we build a model can take months at a time. But what do we like to know, and getting an answer at the push of a button that is just under our fingerprints can be way, way faster. And that's what actually tabular foundation models does nowadays for us. And that's why tabular foundation models have the potential to be like the next revolutionary thing that is happening. Now, that we've seen a prediction generated inside Excel, it's worth remembering that this workflow isn't tied to sales opportunities. It's just an example. We use an opportunity value because it's intuitive and easy to understand, but the same approach can be applied to many different business questions. In customer analytics, for example, it might be churn or customer lifetime value. In financial services, because we have a lot of clients in those areas as well, it could be risk scoring or fraud detection. In retail and operations, if I'm thinking, it could be demand planning, inventory optimization, or forecast future demand. The business questions change, but the underlying idea remains remarkably similar. It means that if I am changing the column names or the observation values, I still get predictions with a high amount of accuracy. It doesn't matter the domain, it doesn't matter the industry. I bring the structured data, I identify what I want to predict, I provide historical examples and generate the predictions. That's what we need, historical examples. That's a prerequisite. That's one of the reasons why tabular foundation models are attracting so much interest right now. They are not designed around a single use case. They are designed to make predictive questions easier to explore across many different business problems. And once you start looking for them, those questions tend to appear almost everywhere. And at this point, it's worth addressing an important question here. If TabH2O makes predictions so accessible, does that mean traditional machine learning model is no longer needed? That's genuinely a question that we could think about. The answer is no, and I consider that so seriously. Like any analogy, the best approach depends on the problem you're trying to solve. So the skill here is also to be able to differentiate how and when to use traditional machine learning from how and when to use tabular foundational models. If you're working with highly specialized requirements, strict performance targets, custom feature engineering, domain-specific techniques, or large-scale production environments, traditional machine learning might still be the better choice. I find it useful to think of TabH2O and traditional machine learning as complementary rather than competing approaches. Sometimes you need a Formula One car. Sometimes you need a very fast train. Both are valuable. Sometimes you need, for example, a bike, right? Both are valuable, but they're optimized for different situations. What TabH2O does particularly well is reducing the effort required to explore predictive questions. It helps teams move quickly from data to production and validate ideas, brainstorm, identify opportunities, right? And once you've identified a high-value use case, you might decide that a fully customized machine learning solution is worth building. This can save you a lot of money and time if initially the idea originates from a place where you already have some form of analytics behind. So this isn't a conversation about replacing machine learning. It's a conversation about expanding access to prediction and giving teams another option between spreadsheets and full-scale machine learning projects. Because at H2O AI, we really think it's important to have both worlds, right? Like we are working with very highly technical individuals who really want to tweak their projects and use our tools in the most refined setup. But we are also working with citizen data scientists, with sales, with data analysts and other types of individuals who don't have that knowledge and don't need to, because there are easier methods right now to reach your results without needing to learn an entire field. Before we wrap up, because I'm aware of the time and we will end in 12 minutes, I'd like to leave you with one final thought. Today we used Excel because it's familiar. Almost everyone understands a spreadsheet. It's one of the simplest ways to demonstrate how a tabular foundation model can turn data into predictions. But the bigger idea isn't Excel here. The bigger idea is making predictive AI available where people already work. For some teams, that might be spreadsheets. For others, it might be CRM a business application, a data platform, an analytics environment, or an AI agent that needs to reason about structured data. The prediction itself is only one piece of the story. What's really interesting is that what happens when predictive capabilities become part of your everyday workflow rather than isolated machine learning programs. Instead of asking for a model, teams start asking more questions. Instead of waiting weeks for answers, they can explore ideas much faster. And I think instead of limiting predictive analytics to a small group of specialists, which is the case right now, unfortunately, still on the market, more people across the organization can participate in discovering opportunities and identifying risks and making data-informed decisions. In many ways, that's the broader vision behind tabular foundation models. Not just making predictions easier to generate, but making predictive thinking more accessible. And I think we're only at the beginning of this journey. I really think that. And so if today's session sparked any idea, my recommendation is simple. Start small. Don't begin with a large AI initiative or a complex machine learning project. Just start with a simple business question you might have in your day-to-day activity, a spreadsheet you already have, and a column you'd like to predict. TabH2O is available for free, and we've included the setup resources, sample data sets, and walkthrough videos to help you get started quickly. So just try it with your own data. It stays with you. The data stays secure with you. See what you discover and use that experience to identify where predictive AI can create value inside your organization. Yeah, so with that, let's move to one final thought before Q&A. When people think about AI, they often think about technology first, models, algorithms, infrastructure, a lot of technical things. But most organizations don't wake up in the morning wanting for more models. They want better decisions. And what's interesting is that those decisions are often driven by questions about the future. If you listen carefully, you'll hear these questions everywhere in sales meetings, in operations reviews, in finance discussions, leadership conversations. They are prediction questions. So for years, many of those questions were difficult to answer because prediction required specialized tools, specialized teams, and significant effort. And what makes tabular foundation models interesting is not that they create new questions, is that they help reduce the distance, as I said, and that is the leitmotif of this discussion, reduce the distance between the questions organizations already have and the answers they are looking for. And if there is one idea I'd like you to remember from today's discussion or session, it's this. The value isn't the prediction itself. The value is in what happens next, the decision you make, the action you take, the opportunity you uncover, the risk you avoid. Because ultimately, that's why organizations invest in AI in the first place, not to build models, to make better decisions. Thank you very much for joining today's session. We are now open for a Q&A section if there are any additional questions we can answer.
Yes, Andrea, we've got several questions here. Some of them you have already covered, but if you want, you can open so you can read them as well. But there's one from Arturo. Does TabH2O work for time series forecasting with mixed variables, numeric, categorical, like a pre-trained model?
That's a great question, Arturo. Thank you so much for your interest and for asking this question. Currently, we have just two options. We have regression and classification. We might include that on the roadmap in the future. That's a very interesting point you're mentioning. It's not currently available, but we are looking into it. Thank you.
Great. Can you clarify the boundary between when to go traditional, for example, H2O3, H2O AutoML versus TabH2O, which I believe you have already covered, but if you want to touch that again real quickly, but yeah.
Yeah, I'm going back to this slide because I feel it's very relevant. when you want simple, quick answers and you have a data set that is already like pretty clean and pretty straightforward with some punctual questions, I would use tabular foundation models with TabH2O. But for more complex questions that require more feature engineering, more tweak to the data sets, more work on the data quality, as well as more integration and like more big data context, I would go with traditional machine learning models. Once again, it's up to the data science team to decide whether or not one is more pertinent than other. But I feel like TabH2O is here to help like the quick analysis to be done before a presentation based on data and not implement and deploy highly complex projects. I hope I answered to this question. Thank you.
Is there a way to get more information about how TabH2O came up with the prediction? For example, which exogenous variable it used, how much weight it put on each variable, what feature engineering it did?
Thank you, Hussein, for this question. That's a great one. The reason why we didn't enter into the technicalities is because like there is a varied background in terms of skills and job titles. I would invite you to go and look up the documentation where we explain in more details how the model for the tabular foundation model has been developed. I'm not sure if Raphael, you want to jump in and maybe give a bit of a detail with respect to that. Yeah.
Yeah, I put in the chat a link to the research paper on TabH2O. So I think it'd be good to kind of, dive into the research paper on TabH2O. But the key thing to note is you have one common model, right? So it's one common model. We're not training new models. And in the future, this is going to keep getting better and better as this one common model is trained on many, many data sets. So we keep looking at, the set of data sets, expanding that set of data sets, and we'll keep looking at expanding the capability of this, common tabular foundation model.
Thank you so much. Yeah, so we wanted to roll out this product because it has been like a lot of our interest was to bring it to the people and to the community as soon as possible. And of course, this is a work in progress that will be developed even further in the future, but it's already good enough for getting accurate predictions. I hope we answered a bit the question, and thanks, Rafael, once again for sharing the link.
Yes, and then we have one more here. I think we have time for one more. Tommy is asking if there's a way to plug TabH2O into a CRM, for example, Salesforce, directly and have it read a specific report and email an output prediction rather than downloading and giving as CSV files to it.
That's a great question. The intention is there. I looked more into the spreadsheets we are currently working with some customers on Excel. I'm not sure, Rafael, if you want to jump in quickly on this one, whether or not you have visibility.
Yeah, so what I would say is out of the box, we have a collection of plugins. So one example of a plugin is Excel, another plugin is Google Sheets. But the key thing is that there's an API, right? So the API can be used wherever you want, right? And so that API allows you to kind of use it within your notebook, use it within other tools, embed it in other applications. And so we'll be looking to expand the list of plugins that kind of make it easier to consume, this tabular foundation model. But at the same time, you have an API that allows you to embed it wherever you want, and now with, vibe coding, it says, hey, vibe coding, choose your favorite tool. Here's an API that gives me predictions, help me build whatever plugin I need to kind of embed it wherever you would like.
Great. Thank you, Rafael. Okay, we reached the end of our webinar. I don't know, Andrea, if you want to give any additional messages for everyone, but I would love to thank you for this great session. Thank you for everyone who joined us today. Thank you, Rafael, for joining us in the Q&A session. We'll be sharing the recording via email, and it will also be available on our YouTube channel. So if
Yeah.
yeah, go ahead.
Thank you so much. The last thing I would say is we have a centralized learning hub called H2O.ai/university. We already have a course that goes through step by step on how to use classification predictions on tabular models and data. And this will be part of the series as well. There are 2 more courses on foundational models, tabular foundation models coming out, and many more others that link to our products. So don't hesitate to take a look at them. The courses are for free. There are also certifications that you can get based on following them. And of course, free spaces where you can practice and learn more about our H2O AI tools. Thank you so much. And last thing here, not to forget for folks, as Rafael said in the comments, in the San Francisco Bay Area, there's a meetup tomorrow. The hyperlink is put in the chat, so don't hesitate to participate to that one. Is super interesting, and I'm sure that if you're interested in the AI world and the latest updates, you will definitely be in that one as well. Have a wonderful day, everyone. Thank you.
Thank you. If you have any additional questions, please don't hesitate to reach out to us. We'll include the contact information in the email that you'll get. Thanks again for joining us. We hope you had a great session, enjoyed as much as we did, and have a great rest of your day.